This video is part of a series, What if the Earth is flat? Now, I was looking at the internet one day and I found this picture, and when I looked at the comments, I saw some people were complaining that it's fake. They were saying it's not realistic, and one of the first objections was the city lights. And they said that's not realistic at all. Who knows whether you can even see city lights from outer space? So I thought, well, I would look into this, and I used Photoshop, and I was able to get rid of all these city lights. And yeah, I would agree that this looks even more realistic than with those stupid city lights in the picture. But then I read further, and there was somebody else who complained that the atmosphere doesn't look realistic. That light blue edge on the shiny side of the Earth, that doesn't look realistic. So what I did is I did some color correction and I removed that. But you know what? That doesn't look realistic to me at all. So I thought I would put it back and I keep the atmosphere, because that looks pretty good. And then I saw people said that those clouds, look at those clouds, even those clouds have realistic shadows. I mean, look at that. You see the clouds, they cast shadows on the surface of the Earth, and then you have these they have a three-dimensional profile to them, because you can see the humps and the individual layers of clouds there, with shadow also casting shadows, a light side and a dark side and so forth. So I thought, well, why don't we take out that all the shadows and see what it looks like then? And that doesn't look realistic at all. Look at that. It looks like just a smudge of white on that ball. But if you don't believe me, I can tell you this is not fake, because if we look at underneath the clouds, you can see here even the mountains cast shadows, and they have a three-dimensional shape. And so with that, I mean, how can you say it's fake? If you remove those shadows, this is what it would look like. Now this looks fake. I mean, look at that. There's not even a shadow on a mountain. So before you call something fake, just because you can't see everything in the picture, maybe you should think twice and ask somebody who knows. Because what you do is, to get a picture like this, with night lights and with three-dimensional clouds and with three-dimensional mountains on the surface and with an atmosphere, and well, you start with a ball, right? You start with a ball that you broke up into little triangles, and then you texture that, and you build it from there, and you use shaders in a CG program. This video is part of a series, What if the Earth is flat? It builds on two previous videos. One entitled How Even a 12-year-old Can Plot a Map for a Flat Earth Using a Stick, in which I covered the math and the trigonometry to plot a map for a flat Earth using a stick. In the second video, I showed how the trigonometry can also be eliminated, because it is built into the shadow of the stick and the stick itself. In this video, I want to give an overview of the method very quickly. So let's get to an overview of the technique. This will be very quick. So suppose you are at a certain location in your city, in the world. So this graphic is a depiction of the real world with the real sun and the real Earth. Okay, it's big, it spans thousands of miles, and we're looking through a camera at the world. And there is a city somewhere that we want to triangulate its position for. So we look at the sun's position at a specific time. We'll call that time number 1. At that time, at our location, we can measure the sun's angle. And all the sun rays that hit the Earth at that angle lie in a cone and hit the Earth in the shape of a circle. And that is a black circle that you see. Your friend in the other city sees a different elevation angle of the sun at the same time. Now all the sun rays that hit the Earth at that angle also lie in the shape of a cone and hit the Earth in the shape of a circle. And that is the red circle. So these sun rays are hitting the Earth simultaneously because the sun is in a specific position, and we're taking a snapshot in time, at a specific moment in time. Now we don't need to look at these cones. These circles give us all the information we need. Each circle represents a sun elevation angle in the real world. And what we want to do at our location is take a piece of paper and plot the other city on this piece of paper with respect to where we think we are. So we can mark our location, and now the objective is to find out where on the map is the other city. And we will repeat this as many times as necessary for doing hundreds, if not thousands, of cities to get an actual map. And I'm going to focus on just plotting one city, and then that can be repeated for all the other cities. So what you do is you plant a stick and you obtain a shadow on the piece of paper from the stick. What you do, you extend the shadow by its own length using a ruler in the opposite direction past the stick. So there's the shadow and there's the line. And the end of that line now represents the center from which we can draw a circle. And that also represents the height of the scaled version, a scaled miniature imaginary sun that we'll be using on our map to do the triangulation. So this is not the real sun. This is a scaled version of the real world, including the sun, because we are actually trying to scale down the green Earth with the cities and the sun and everything. We're trying to scale it down to fit on a sheet of paper. So this position that we just marked represents the location on our map where a scaled imaginary little sun would be located. And that is from where we can draw elevation angles on the map. So that little sun also casts imaginary sun rays at the same angle that we measure. So we can get a new circle. And that circle and cone that I just drew, this blue cone, represents the yellow cone that we saw before. And we have then a circle representing that sun angle. Now, we also want to plot the red circle. And the red circle was obtained for the sun at the same position. So we use our imaginary little scaled sun, which is the height of the stick above the center point of that, or the end point of that line. And you plot the shadow that your friend in the other city reported. And that gives you the exact same angle that he saw, but in a scaled version for your map. So now you have two circles. You didn't have to have an actual sun there. This is all imaginary. You're just drawing circles with the radii equal to the shadows. And those two circles represent these cones of sun rays. Now suppose that the sun moves to a new position and we find these circles at time number 2. So the circles that we measure intersect our locations again and must intersect the other circles that we drew before. They must. So we're going to reproduce that on the map. We take our sheet of paper and look at the shadow that we get from the stick, where the sun is in position at time number 2. We extend that shadow past the stick in the opposite direction by the length of the shadow and mark that position. And that position is where the sun is directly overhead on our piece of paper. Not the real sun, but an imaginary scaled little sun. Scaled down to the scale of our map. So you can draw the circle with a radius equal to the length of your shadow. You ask your friend in the other city what he measured at that moment, and he gives you his shadow length, and you draw a new circle with that shadow length. And now you have a new circle that represents the angles of the sun that was measured around the imaginary little sun on our map. And his location lies somewhere where the two red circles intersect. We can then do a third measurement to pinpoint the triangulation and pinpoint the location of that other city. So the sun's position is now at time number 3. We get new circles, and on our map we repeat the entire thing. And we get a third set of circles. Now if you just take away the stick and all the other lines now, you'll see that the red circles intersect in one point and the black circles intersect in one point, just like they are doing in the real world. So if we zoom in, there you can see it better, how the red circles intersect in one place and the black circles intersect in one place. Zoomed in further, now we can mark those two positions. One is your own city, the black circles, and the red circles intersecting point is your friend's city. And so back on our map, we can delete and erase all the circles, and we remain the 2 points. One on the left is the city that we wanted to triangulate. The dot on the right is your own city. And that is as simple as this technique can be. And that is how simple it is. Anybody can do it. Even a 5-year-old can do this. In one of the videos I also showed that we can accommodate different altitudes for the sun at different positions and times. So as the sun moves along, we don't have to assume that the sun remains at the same altitude above the flat earth. To accommodate that here, you are very free to incorporate your own scale factor. So if you want to make the map 50% its original size, or half as big, then just multiply all the shadows by that percentage. So multiply all the shadows by 50% before you plot the circles and before you draw the lines. And that is as simple as it is. Everything scales beautifully linearly.